The current surge in energy prices is a major stress test for the manufacturing sector. But what if this crisis also allows us to fully integrate sustainability into key decisions? How can we make manufacturing less resource intensive? Can we make the industry greener, more circular, and more resilient? At EIT Manufacturing, we aim to drive the industry forward. We need to face climate change, energy shocks, and supply chain issues. But to do so, we need your insight and expertise. Be part of the change and help accelerate the transition to a more resilient European economy.
Hello. Good morning, everyone. And to our virtual audience, good morning from Brussels. My name is Karen Helmstedt, and it's a great pleasure to welcome you to the 2022 edition of the EIT Manufacturing Summit. Well, we're coming to you live from the EIT house this morning here in Brussels with a studio audience. And let's have a bit of a wave and a cheer from them so you can actually feel that there's some energy in the room, some warm bodies. Fantastic. And we are, of course, hoping to connect with as many as possible of you from the manufacturing community out across the cyberspace and all across Europe. So thanks to all of you for tuning in and joining us. Well, needless to say, everybody, we find ourselves in an absolutely unprecedented situation here in Europe. And if we thought the pandemic that we've just gone through for the past nearly 3 years, or 2.5 at least, was a crisis, well, we have indeed been made to think again. Russia's war in Ukraine, as we saw just yesterday, is getting worse by the minute, and the resulting energy insecurity that has come from it has completely changed the landscape that we're dealing with. So while climate neutrality by 2050, of course, as part of the Green Deal, is still top of the agenda here in Europe, the question is how surging energy prices and the consequently rising material costs, of course, will influence the speed of change. Well, as we all in this room here know, nearly everything around us is touched by manufacturing in some way. And yet we're increasingly aware of environmental impacts. And coming off of COP27, which we just saw in Egypt, of course, we're aware of the fact that many, many nations are slipping on their climate targets. So our overarching theme for today, everybody, and you can see it on the screen here behind me on the decoration, circular manufacturing for a more resilient European economy. And today we'll be spending some time discussing different approaches to the challenges the ecosystem is facing. And of course, on day 2, because we are here for 2 days, we'll be showcasing the finalists of EITM's outstanding competitions. On the one hand, the Regional Innovation Scheme Leaders competition, and then the Teaching Factories. So we've got an action-packed day tomorrow as well. Now, before we proceed with the subject matter for today, I've got a couple of quick technical remarks. We're using Hopin, the platform many of you will recognize from last year. So for questions related to our topics today, please just use the chat button at the top right hand of your screen. And for those of you, any of you using social media, the hashtag is, of course, EITM Summit, as it was last year. So be sure to follow the conversations there. A reminder of the virtual breakout rooms during the lunch breaks for our virtual participants particularly, where you can find further insights and a lot of results from the projects and initiatives that are happening in 2022. And if you, by any chance, need any further help, please use the frequently asked questions button, the function, and we will do our very best to assist you. Well, with that, let's get started with the meat of the matter, and it is a great pleasure to welcome Klaus Beetz, who is the CEO of EIT Manufacturing. Let's see if we can pull him up on the screen. Good morning, Klaus. Great to see you.
Klaus, good morning, Karen. Good morning, all the people in Brussels. And I have to apologize. You know, on short notice, I had to change my plans for urgent matters. I had to travel to Paris. In our headquarters, so unfortunately I could be not in person with you like we have been last year in Berlin.
That's right. That's right. I was hoping to see you in person, but it's great that you are able to join in from there. So a warm welcome to you, Klaus. And joining us also online, we're just going to slide you over on the screen and add Cecilia Worrell, who's tuning in from Scotland. And Stockholm, not Scotland. Where is she? Let's see if we can get her on here. Cecilia is online. There she is, the chair of EIT Manufacturing Supervisory Board. And it's great to see you as well, Cecilia. How are you? I hope all is well in Sweden.
It's okay in Sweden, getting a bit colder, and we are sweating like many of you in Europe around the energy prices. But very nice to be able to be here, although in digital version. And I've seen some of my friends there in the audience. So hi, everyone.
Okay, well, welcome to both of you. Klaus, I think, as we know, I'm going to start with you, because it's been a very eventful year since we met last year in Berlin. This is the third event of the EIT Manufacturing Summit, of course, and I know you've been incredibly busy. So give us a quick overview of what you've been up to and what you've been doing in the past months.
Yeah, okay, yeah, you are right, Karen. Time is really running, and but for me, the most exciting work was the development of the idea around the European manufacturing system. The idea behind our European manufacturing system is the following. First, putting really sustainability in the focus. Manufacturing has been always driven by the triangle of cost, quality, and time. And we have to take sustainability, consuming less energy, reuse as much as possible raw materials, but as well as prefabricated parts, and of course, the decarbonization of industry. We have to take these topics at the same level as cost, quality, and time. And we have to integrate sustainability into all our methods, our processes, our thinking. And therefore, we have to rethink manufacturing. We have to rethink what we manufacture and how we manufacture. Further, we have a lot of upcoming manufacturing technologies like additive manufacturing. We have a lot of upcoming and emerging manufacturing methodologies, like moving from the fixed predetermined production line to more flexible, autonomous, self-organizing production unit, or new value chains like manufacturing as a service. We have to integrate, and this is a very fragmented landscape of technologies, methodologies, value chains. We have to integrate this in a holistic view. And last but not least, we have to put our biggest asset, and this is our experienced and very well educated workforce in the middle. People will also in the future remain an integral part of our production processes. Therefore, we have to look at manufacturing as a socio-technological domain. And we have to look at technologies from the people point of view, that the technologies augment and support the capabilities of human beings. And that we really establish a working environment where human beings and technologies complement each other. I'm therefore also very happy that EIT Manufacturing was nominated to coordinate one of the flagships of the new European innovation agenda, the Deep Tech Talent Initiative, with the goal in the next 3 years to educate 1 million European citizens in deep technologies.
Congratulations on that news, Klaus. Thanks very much for that overview. And it really is interesting because it's become so multi-layered, hasn't it? It's really like we have to create a new manufacturing system, which is what you were describing there. So Cecilia, over to you, because of course the geopolitical situation has changed dramatically across Europe, as I mentioned in the introduction. Particularly for Sweden, a country that is in the process of fast-tracking its membership into NATO. You also have a new government. And yes. I'm assuming foundations have been shaken all across the industry. Just tell us what you're hearing. What can you tell us?
Well, as far as NATO, I know that that's a political discussion that's going on behind closed doors at the moment. And one of the vice ministers from Turkey is going to be in Sweden in the next couple of days. So I'm not going to talk so much more about that. We have a new government that is more right-wing today for the coming 4 years, and they are traditionally very difficult to lure into funding collaborations between industry and research, which is a big That's quite a big risk that we're taking in Sweden. At the same time, I can just tell you that Swedish manufacturing industry, which is usually very innovative and usually Sweden usually tops the list when it comes to more innovative countries around Europe. And there is so much positive things going on now when it comes to battery production, circular business models, very new ways of mega costing in the automobile industry that will take a lot of the sustainability risks out. And so there's super many interesting projects going on. And I also want to touch upon what Klaus didn't mention before, that EIT has expanded substantially this past year with the new CLC in Athens. We'll probably go back to that. But I think from our perspective, it means we are now covering really all of Europe, not to mention the southeastern area, which is quite large. And therefore, from my perspective, I see that we're really building resilience now. We are connecting so many more actors in the knowledge triangle, in the supplier network across Europe. And what Klaus was mentioning, putting people in the center, reskilling and re-educating workers, companies, and also involving more of the research community and industry. We will now expand that network even further. So EIT is really building resilience for the European manufacturing industry in this way. And that makes us more resilient against current problems, wars, etc. And we will probably see more of those negative trends in the years to come. So Europe is a factor that will continue to build strength through EIT manufacturing.
This is good news.
Really exciting, yeah.
This is very good news, Cecilia. Thanks very much. And thanks for mentioning the new CLC Southeast in Athens that was just inaugurated in October. We will be having the new director, Nikki, join us in tomorrow's session. So that's very exciting news. Now, Klaus, back to you, because the theme this year is circular manufacturing for a more resilient European economy. And in this new climate that we've been talking about, what are your main focus points for increasing circularity?
Yeah, first of all, we have to look on the transition towards the circular economy as an opportunity and not as a challenge. From my point of view, there will be a market for remanufacturing or for green technologies in general. And there is really a very good opportunity for Europe to become the leader of this market, selling green technologies all around the world. Take the example of battery production. We are currently building in Europe a lot of new production plants for batteries. And all the raw materials needed, like graphite, manganese, cobalt, lithium, and so forth, are not available in Europe. So recycling is a must to become, at least to some extent, independent. But there is also a market opportunity to sell these technologies around the world. So we have to look really at the opportunities. And I'm very happy that we support this development in this year. Just to mention one project we have running in 2020, this is about the automated dismantling of batteries. And also this will be a technology which really shows also the multiplier effect of our innovation activities. Such an innovation will be used in several or many factories and plants around the world, and the impact of the innovation will be multiplied.
Thanks very much, Klaus. Now, Cecilia, we are getting kind of tight for time, so I'm just going to squeeze in one more question for you. Now, I'm going to possibly sort of combine a few things, because one of the biggest challenges that the industry and all industry sectors are having to deal with, of course, is the high energy prices and fears of a recession. So this is having an effect on manufacturing, and we'll be discussing that. But do you see this crisis as an opportunity to accelerate the transition to sustainable manufacturing?
Well, absolutely. There's no alternative. Looking at most of Europe's industry from across the continent, many of these companies have been around for quite a long time. I mean, Siemens, the auto industry, the Swedish ABBs, and all of those type of companies have been around since early 1900s, and they've always managed to change, optimize their business models, and adapt to the current situation. This will not change this time around. We have an energy crisis, of course, going on. I'm very positive that all our large companies will manage to pull through. They will work with their suppliers because these are very, very important parts of manufacturing, help them pull through as well. There are several programs going on in Sweden at the moment regarding energy, saving energy and new technologies for that. And those will come into action already now and be running for a couple of years. And I'm sure that many other countries have the similar kind of actions going on. But surely energy will be an opportunity because we will have energy type of manufacturing companies getting out there and creating more business. Hitachi Energy is a Swedish-Japanese company that is in that space. And we will see many, many more efforts around that.
And a lot of collaborations, which of course you just indicated in
Yes.
mentioning that particular company.
Just to mention, manufacturing is a very creative business. It's super innovative. It's super fast. So I wouldn't be worried about that. But of course, we will all be seeing higher prices for some time.
Okay, thanks very much for that input. Now, Klaus, I think unfortunately we've got to get moving. So I know that you're looking forward to today's discussions, and you'll be joining me again to close the day. So thanks very much to both of you for joining us and getting things kicked off. It's really become something of a tradition between all of us. Mm-hmm. Makes for a great transition to our roundtable discussions. So thanks very much to Cecilia Worrell in Stockholm and Klaus Bates in Paris. It was great to have you with us here.
Thank you.
Thank you.
And with that, for our studio audience and our virtual, we can proceed to our first roundtable, Building Innovation and Skills to Optimize Energy Consumption During Manufacturing Processes. Well, the digital transformation and the fifth industrial revolution continue to redefine manufacturing jobs of the future and of the present. And what we want to do today is look at how the current energy crisis can help accelerate an even faster transition to circular manufacturing, as we just heard there, and of course see how the changing workforce environment focused on advanced technologies and digital skills can actually support energy efficiency. So here to talk about this today is a distinguished group of panelists, and I'd like you to please welcome here on my stage Paola Fantini, who is the Director of Education at EIT Manufacturing. Give her a bit of a round of applause here so that we know we have an audience. Martin Mühlbacher is Vice President of the Jenbacher Operations and Executive Site Leader at INEO, and that's an energy solution and service provider based in Austria. Warm welcome, Martin. Bastian Tiede is also up here on the stage with me, Team Leader at the Learning Factory for Digital and Sustainable Production at the Technical University in Braunschweig in Germany. Welcome. And we have a bit of an extended roundtable today because we have Bruno Puzzolante, who is joining us in the front row. He's Senior Project Manager and Coordinator of Smart Industry Solutions Unit at Cefril, which provides IT services and consulting in Milan. And Cefril is also an activity partner. So we'll be hearing from Bruno on two levels. And Cosmas Alexopoulos is also here with us. He's a software engineer and senior researcher from the Laboratory for Manufacturing Systems and Automation, shortly known as LMS. We'll hear more about them at the University of Patras in Greece. A warm welcome to you. And finally, a warm welcome to all of our activity leaders. We'll get to their names later, who are in the audience here with us today in Brussels, and we look forward to getting some insights into your projects later in the discussion. So welcome to all, and thanks very much for joining us. Skills and innovation, really, to optimize energy consumption. That's our starting point, and I'd like to really begin with those main concerns that everyone has, which is energy and CO2 reduction in this discussion and on today particularly. And of course, it's very controversial always, isn't it? Because manufacturing is often perceived in the public realm as being not clean, as being heavily energy intensive. So Martin Mühlbacher, I would like to start with you because you've got really this incredibly broad portfolio of functions in your function at INEO. But essentially what you're doing is helping companies to find solutions for power generation and sustainable energy management. So navigating all the time, of course, this incredibly fast-changing landscape with the green and renewable energy sources coming in. So could you tell us, how can smart energy management actually accelerate the progress on both of the goals that we're talking about, so reduction of CO2 and also transition to circularity in manufacturing?
Yes, sure. So smart energy management can contribute to both, and we need to see both as very, very important elements going forward. So first of all, with smart energy management, we really need to better manage our hardware. So for example, in our case, we have a large manufacturing site, 2,000 people, 10 megawatt hours of peak power need for the factory. And we produce with our product our energy on our own. But we need to manage this digital. We need to manage this artificial, because there are so many informations coming together. How is the energy demand now? How is it in the next hour? How is it during the day? What is the weather forecast? What is the temperature? What is the heating demand? How many people are in the factory? How many people are hybrid in home office? How many shifts are online today? 2 shifts, 3 shifts. And this algorithm manages then the software, the hardware. And this teaches then the engine at our factory, run how long, stop, whatever. And this, let's say, smart grid as well combines old traditional energy sources, like an engine driven by natural gas, and in this microgrid, a photovoltaic system, a battery storage, a power-to-heat model, a small hydro plant. So we have all those in our smart grid environment in our manufacturing. And all of this is very important to reduce the CO2 footprint, that only at this time when energy is needed, an engine runs and produces CO2, and not it stops. And in between, there is the renewable energy from the photovoltaic.
So thank you for that incredibly detailed description. And of course, we can see the complexity that we're dealing with here. And you mentioned digitalization. So I'd like to go to Bruno Puzzolante, perhaps, because we do have this sort of a combined panel going on here, because your key area of expertise is definitely digitalization. And you're very involved in supporting SMEs, which I can imagine are having more trouble with this kind of complexity than larger companies. And we know that we have disparities between regions in Europe. So could you perhaps just describe the current role of digitalization in manufacturing and how it can help to solve the most pressing challenges, also from the SME point of view? We have some sound on Bruno's microphone. Let's just make sure it's on.
Okay.
Testing. We can hear you now.
Okay,
go ahead.
Perfect, thanks. Let's start from the digitalization. That is, let's say, the main component of what have been the Industry 4.0. What we are facing currently with the energy crisis is that we are moving from what it was the fourth industrial revolution to a new paradigm that is the fifth industrial revolution. It's not a new paradigm that is in substitution what was the Industry 4.0, but it complements what we have done till now and what we are doing right now with the digital technology in the manufacturing field. The Industry 4.0 had the sustainability, the resilience, and the human at the center. So these aspects become really fundamental to drive and to complete what the digitalization is doing in the manufacturing context. Usually when we are talking about manufacturing, what happened in terms of use cases for digitalization, we were thinking, as an example, to improve the product quality. This means introduce technology on the shop floor to make it possible to collect data, understand where it was the issue to fix, how I can improve my product quality in the shop floor. And this, as a consequence, also brings to somehow to the reduction of energy use, because if I reduce the energy spent for product that will be discarded, so at the end, as a side effect, also I'm going to the reduction of the energy. But with the energy crisis that we have currently, what we are facing is that the fact that the use case in this case become the how I can reduce and I can optimize my energy consumption. Mm-hmm. So this became the main use case, the main elements in the overall equation that I should optimize. And the digital technologies come in play, in the playground, to help the collection of data, the analysis of data to different levels. So talking about disparities between regions, between the different manufacturing that you can have, especially for the small, medium enterprise, you can start from just collecting data, understand what is my consumption at a high level, so what is related to the billing aspect, but time by time going also in deep for all the production line. Going to more advanced manufacturing plants, you can see and you can correlate this data together with all the other data that are coming from the production. So you can build on it application to optimize, take into account more and other aspects that are related to the production, to the operation, to the quality, and to the maintenance.
Thank you very much, Bruno Puzzolante. Cosmas Alexopoulos, would you like to add anything to that? And I'm wondering if you can just sort of tell us about the current state of technologies in manufacturing.
Yes. Here in the late years, and also following Bruno's thinking, we have seen a lot of mainly digital technologies that have been introduced in manufacturing. Mm-hmm. I could name a few, like industrial Internet of Things, that are there to help us. The key issue of data gathering, that is important when you want to have more insight into the manufacturing process. Other technologies like augmented reality or virtual reality to help supporting the operators, for example, through remote assistant. We have big data and analytics that are there to help us with improving our processes. I could give an example since we want to see how energy puts some new challenges in manufacturing. Now companies need to be more creative, more innovative, and more flexible, as Klaus mentioned in his introduction. So, for example, they are looking at ways to change their process plan, to change how products are being produced. And this is not a simple thing to do in manufacturing, because these are well-established processes. And if you want, for example, to change the treatment of a part that it's energy-intensive, with another process that follows up, that is, let's say, curing of the part, then there you need indeed some strong support from new technologies like the digital twin to help you with a simulation of the process and help you get more insight into the decision-making process that you are facing upon. Mm-hmm. So digitalization is, of course, one aspect, but there are also other, I would like to call cross-cutting aspects, like skills that we need to take into account, but maybe we can take this topic in a later discussion.
We definitely will. We'll pick up on that. Thank you very much, Cosmas. And Bastian Tiede, back up on stage here. I'm wondering if you can possibly add to this. Obviously, companies need to be more creative. Digitalization is very much incorporated, and anyone who hasn't come along has missed the boat. But perhaps you can tell us also so your reflections on what the two colleagues have said first, and then I've got another question for you.
Yes, thank you. So first of all, I can totally agree what we already heard. It's pretty much about increasing effectiveness or effectivity of the processes we have. So either become more effective by maybe adding some new technologies like AI in production, like data mining, from all the digitalization as an enabling technology, or on the other hand, introduce new techniques, new technologies, maybe rethinking a little bit what the actual need of the customer is, and take a step back, reevaluate the issue or the problem, and come up with new solutions, with new integrative solutions to fulfill the customer need in the end.
Okay, and because of course we mentioned the fact that we do have these disparities across the regions, Europe being obviously a relatively vast continent, how do regulation and optimization of energy consumption vary across Europe itself?
Yeah, that's a very broad topic you bring up there. So first of all, I think it's pretty good to see that the European Union is very much driven to accomplish its goals. For instance, to increase energy efficiency by 32.5% by 2030. And nations are called in a nation energy and climate plan to pinpoint what are actual measures, how they gonna implement them, and what the actual results are.
So that's the individual member states.
The individual member states. And I think that is, on the one hand, a good approach because every nation will deal with different circumstances. And interestingly enough, some of the so European Union is actually evaluating what are the measurements that have the most impact. And at the moment we see mostly tax mechanisms to try to force industry to answer this question, funding schemes, and as well the energy efficiency obligation schemes. So really pushing industry to save energy or increasing energy efficiency based on the products for end use.
And despite all of the jargon, are you confident it's going to go forward? It's not going to be too complex?
It is complex, and it's getting more and more complex. I mean, we already talked about circular economy if we want to integrate all of this. Yeah. However, from the perspective maybe of a single enterprise, of course, they need to deal with circumstances they have on site. And if you think of, first of all, as a major task to reduce overall energy consumption, which is always the best. If we don't need the energy from renewable sources, we don't need to really care about, or we can use it somewhere else. So we don't need to increase capacity for renewable energy sources. So this is always the first go-to. But on the other hand, we also need to think about when are we using the energy. And this is also what Martin already mentioned. Mm-hmm. We need to transfer from a matching of demand with supply to the no, we need to go there actually, because nowadays we have a certain demand and we try to match it with the supply. Now we have to, we have the available energy from renewable sources, quite volatile, depending on where you are. And here the regional aspect again comes in. Depending on where you are, you need to adjust your production, you need to adjust your demand to the available sources. Mm. Then, of course, we also can speak about integration of other energy systems or networks. We need to talk about energy storages or diversifying the energy sources, as we already heard from Martin very well explained. So there are a lot of small measures you can take, but you also need to keep in mind.
Okay, so anything you'd like to add to that, Martin, having heard all of this input?
I absolutely agree on your opinion here, and it needs to be an energy environment with different sources for supply and for demand. So as I said, on the other hand, you have renewable energy sources. They are great, they are CO2 free or at least CO2 neutral, but they are very volatile. And on the other hand, you have traditional sources where you just need to push the button like on our engine, and then it runs, it starts off, and it supplies then in this peak time this energy which is needed, but only for this time, and then it stops again, and the renewable takes it over. And on the other hand, on the demand side, battery storage, really important. I think there will be a huge development over the next 3 to 10 years, I would say. On the other hand, hydrogen. Hydrogen is really a great opportunity going forward to store here energy on a large scale. When there is too much energy on the grid, put it into the electrolyzer, in an electrolyzer, store it under high pressure in a storage for hydrogen, and then later, when the energy demand is there, when the peak is there, use it and burn it then, for example, in one of our engines and produce the electricity spot on at this time for this period. And this will be really, really important. going forward to balance this. And to balance this, you need a software. You need an artificial intelligence.
Okay, so we'll get back to the artificial intelligence and, of course, to the hydrogen in more detail later. But I want to get to Paola Fantini, who's sitting here also up on stage. And as Director of Education for EIT Manufacturing, you're, of course, have a particular focus on skills, and skills were mentioned by Cosmas earlier. Tell us which skills are going to be relevant for this idea of reducing energy consumption all over the place, and are we going to run into problems there?
Yes, thank you. Of course, it's a very broad range of skills. We have been listening to how many levers, how many layers are relevant when you want to reduce energy consumption. So you need to identify the wastes. You need to analyze the data from your hardware, not the hardware that produces energy, but the hardware of the production line that consumes energy, and optimize it. Or you can replace some technologies like pneumatics, for example, that is more energy consuming with some other technologies like robotics or another type of automation. You can also think of changing the complete design of products in order to be circular, to be reused in components, remanufacturing, etc. And this is the best way to reduce energy efficiency. But you can also think of products along the life cycle, meaning that you want to reduce the consumption during the use, when the user is using the machine or the object. So it's a very large spectrum of activity that you need to do, and the corresponding skills are quite wide. So we have, for example, in our offering, master courses, EIT labeled, that provide, that focus on artificial intelligence and machine learning for competitive manufacturing, where also the energy consumption is analyzed, and they provide with a wide range of skills to the students in order to be able to address and understand the complexity of a manufacturing system along their life cycle. Or we have another master program on zero defeat or zero waste manufacturing for circularity, where all these aspects are taken into account. But also we can have very small learning paths that provide with maybe tiny skills that are quite important, like identifying the wastes. What are the types of wastes that currently companies have? So this is the first step for companies to analyze and think of possible solutions to address. Or we can also have a very specific learning path to provide skills on very specific topics, like how to be energy efficient when you have laser-based processes. So, well, I'm sorry I couldn't provide one answer, but I hope I've given the variety of skills that are requested to address this challenge.
Definitely the idea was for you to list a number of examples of how EIT manufacturing is actually addressing the skills shortage that we also see approaching as more and more companies have to sort of get into this kind of sort of transitional matrix, if we could call it that, of energy sources that Martin was talking about, which means that we could, I guess, go to the projects, if you will. Do any of our main panelists here have anything else to add? Because I would like to go to the projects. Any hands going up? No?
Only one thing.
Yes, Martin.
Circular manufacturing, because this is a key theme today, right? Yeah. So on our side, we are really glad that already 50% of the volume of new products, new energy solutions, we give 50% into the circular manufacturing process. 50% of the volume, which means 500 engines out of our factory go out with a second life. So here the good thing is our product is mainly made of steel, of iron, and we can reuse here many, many parts. And over the last 10 years, I would say, we transitioned more and more not to replace the part, put it in a basket and bring it back to the melter and just melt it and then reuse it because it's already a first reuse. No, we are walking away. We reuse the part. We just clean it. We just control the quality. And it was surprising. In many, many cases, we can just reuse it.
So we're talking more about a move towards a refurbishment.
Right, a refurbishment, and it starts with only cleaning and checking the quality. And then the next step, if cleaning is not enough, and the quality check says that some diameters are not correct anymore, are out of tolerance, we remanufacture, we call it reman it. And we put it to an oversized dimension with thicker bearings, for example, in the engine, and we can give it a second life. And such an engine life is 10, 15 years. And we prepared it in our design to give it a third life. And we are even thinking to extend this. And we extend more and more parts. And with that, we do something great for our planet, because you don't need to melt the part, you don't need to cast it again, you don't need to forge it again, you don't have long transportation ways, either from Europe or either many of our suppliers are in Asia. So it's really a very, very strong element going forward, this circular manufacturing. And more corporations need to do this going forward to save the planet. Yeah?
Thank you very much for that example, Martin Mühlbacher, designing for longer life cycles and getting into a more refurbishment, reuse mentality. And hopefully that's something that we can possibly even hear is happening elsewhere across Europe. I'd mentioned that I wanted to go to the projects, and just a reminder to our virtual audience that you can put your questions related to the roundtable theme here today and to the projects that are sort of coming up in our discussion into the chat, and we'll have an opportunity to look into the chat and possibly answer a few of those later at the end of towards the end of the session. But I'd like to bring in the first one. I think is Nicola Doppio is here with us today, and he's brought a project that he's going to present called FlexMan, which offers a transformational program for manufacturing SMEs with a demand to swiftly integrate tailored solutions for flexible manufacturing. So flexibility, much like what we were hearing here. Nicola, welcome, and perhaps you could just explain how this project itself is contributing to circular and sustainable manufacturing.
Yeah, thank you. Good morning, everyone. Thanks for having me. It's great to be here face-to-face again. So yeah, I work at EIT, Hub Innovazione Trentino. We're based in Trento. We're a tech transfer foundation, and I'm coordinating Project FlexMan. We make available professional training to manufacturing SMEs that are trying to shift to more flexible and resilient manufacturing practices, because of course they need to face the great challenges that came with COVID-19, so disruptions in the supply chains, in the markets, in the industry, and more recently the energy crisis. So what we're doing is to make available professional training about technologies that can help companies become more flexible and resilient in their own processes. For instance, we have modules about electronic data interchange in the supply chain that can help companies understanding to what degree there's availability of parts in the supply chain and to what degree they can meet their production planning. Also, we provide training about AI, of course, and this is relevant because it can be used to optimize production planning and to adopt more opportunistic scheduling approaches. And we provide training with, about other different modules such as digital twins and industrial IoT. So we make available slightly different version of the FlexMan program in 4 countries because we know that we have different needs in SMEs from the different countries: Italy, Spain, France, and the Czech Republic. We do an analysis of needs before providing the training. And the other interesting way is that we don't train professional single employees. We train entire teams that are made available by companies, so like 5 to 8 people, because we know that in order to integrate those solutions and those technologies into a SME, it requires a coordinated, orchestrated effort involving departments such as IT, logistics, legal, so not only we train blue collars, but also white collars. And so why is this relevant for energy efficiency? Well, of course, if these are digital technologies. So going digital is the bottom line for a company to understand what's going on, okay? So the module about industrial IoT and machine sensoring is basic for companies to understand what machines in the production line are consuming the most, where is actually happening the higher consumptions. Then on top of the data, we have a module about a smart plan architecture, so how to really make the best of data. We have modules about AI and machine learning, so how to handle the data and how to make the best of it. And if we have more time, I will also tell a story about how companies are now doing artificial intelligence on data set to optimize the energy consumptions. I can cover that later. And with smart, with digital twins, you can simulate processes before going live, so you can hopefully make the best of the process and reduce scraps and energy use. And also we have a module about sustainable plant, at least in the Italian version of the program. And in that case, one of the company which is going through the course in Italy, they develop parts for large car manufacturers such as FCA and Volkswagen, and they are asked more and more to be accountable about ESG responsibility. So they don't know how to handle that, and they are appreciating a lot of the fact that we are really providing an entire model about sustainability. So not about technology, but how to leverage on technologies to be also more competitive into their own industry.
Okay, thank you very much. And perhaps I could invite you to elaborate on that one example that you wanted to bring, because I'm wondering about your expected outcomes. And you mentioned you're in 4 countries. Do you see expansion also in the further continuation of the project?
Yeah, well, we are asked to bring the course into the market after the end of the project, so we're working on that. But another interesting thing about FlexMing is that it's not only about training these teams, but it's really to get these things going. So the sort of second part of the program is really about acting. So we help these teams to identify use cases and to prepare projects to implement those technologies in their own companies. And we make that happen by opening the participation to the companies to innovation challenges and open innovation contests. That's the way we're doing that in Italy. We have a contest which is called the Industrial AI Challenge, where we have university students mentored by researchers and startups that are working on actual challenges provided by the company. And in this edition that we are having this year, we have the largest apple producer in Trentino. In Trentino, we produce a lot of apples beside grapes and wine. So this huge consortium of 200 apple producers have to store a very, very large quantity of apples between September and August next year. And they do that in refrigerated cells. And the cost of the refrigeration amounts to 70% of their overall energy costs, and this cost went up 3x during the last 12 months. Mm-hmm. So what they're doing is using the historical data of the functioning of the cooling system to optimize the way that the cooling liquid is produced into the cooling system, and it flows into the different cells in the many warehouses that they have to save energy. So that's the way that we gave a very practical flavor to this FlexMing training program. We ended by having companies taking part to this open innovation contest, which of course produce proof of concepts, but more often prototypes of solutions that can be taken up into the company, hopefully also with the help of the startups and the researchers that played the role of mentors to the team. So that's the way we do it.
Thank you very much to Nicola Doppio for that brilliant explanation of the project FlexMan happening in Trento. Does anybody have any questions for Nicola at the moment? I think we'll move on to the next one. And I'm going to come back to you, Martin, in just a second. But let's bring another project in because Smart DG is also represented here in the room. And Anna Maria Corfiati is here. Now, Smart DG is focusing on boosting the participating risk countries' innovation performance by improving their educational scheme and promoting digitalization with respect to Industry 4.0. Could you just tell us a little bit about how that is contributing to energy reduction and to circular manufacturing?
Hello, thank you for the invitation. I'm Anna Maria Corfiati. I'm a mechanical and research engineer, and I work at the Laboratory of Manufacturing System and Automation. We all know that digitalization helps manufacturing companies to be smart and more sustainable. Digitalization with the real-time collection and analysis of data help the companies, the SMEs.
I'm just being asked, could you stand up? Because we can't see you back there, and I think the camera wants to get on you. So, very much. Thank you.
Digitalization, as I said before, help with the real-time collection and analysis of data can help the manufacturing SMEs to identify their problems that can cause material waste and other unnecessary energy losses. So, the challenge that the Smart Digi project is ushering to is the lower performance of EIT risk countries than the European Union average regarding the development of advanced digital skills of the workforce from manufacturing SMEs, as well as the integration of digital technologies. So, the idea of this project is to reinforce the innovation potential of the participating EIT risk countries that are Greece, Lithuania, Spain, Czech Republic, and Bulgaria, and by changing the educational schema and developing their digital technologies and digital skills. So, the Smart Digi project aims to develop and deliver a training program where industry and academia, students, researchers, and employees from mainly SMEs develop their digital skills through co-created solutions to real manufacturing challenges. Part of this training program, is the design, organization, and implementation of teaching and learning factories, as well as organization and implementation of an open information event where representatives from industry and representatives from academia can share their ideas, their visions about how we can solve the future challenges of the manufacturing SMEs with digital technologies. This is the whole idea, the whole concept of the Smart Digi project.
And in terms of outcomes, what are you expecting?
So, during the project, we develop and establish 5 local nodes. These local nodes were established by both industrial and educational partners of the project in Greece, Lithuania, Czech Republic, Spain, and Bulgaria. These local nodes facilitates the collaboration, communication, and learning between these countries. So we organize and implement 5 teaching factories involving 5 different manufacturing topics and more than 40 participants, mainly from SMEs in these countries. We also organize and implement one learning event that involves 3 universities from Czech Republic, Greece, and Spain, and more than 60 students. And last but not least, we organize and implement an open information event where many stakeholders from these countries participate and share their ideas about how we can integrate digital technologies to SMEs in order to solve the future challenges.
Thank you very much. Anna Maria Corfiati, who has just presented the Smart DG. And Martin, I thought just with everything that you've heard now, and we were talking obviously about these regional disparities and we see what's going on sort of in the risk countries, and you mentioned hydrogen earlier. Do you see this energy crisis as spurring sort of an unprecedented push of innovation across manufacturing, even with what you're noticing around with your customers and suppliers as well?
Absolutely, yeah. There is a much stronger push to become independent, from natural gas, coming mainly from a country which is now in a war, right? So we all know how difficult this is, and hydrogen is one important answer to that, to become more resilient as Europe. And as we push here dramatically renewable energy sources like wind, like solar, like hydro, as I already mentioned, those are very volatile. And there will be times when we have way too much electricity in the grid, and you can instabilize a grid in two ways. When you have a too low amount of electricity, like we see now in the Ukraine, and hear and read and listen, right? But on the other hand, you can overload the grid. And with hydrogen, we can avoid this. Because when we, as Europe, invest here heavily in electrolyzer plants, when we see that the grid is overloaded, for example, on a summer day in August, when it has 35 degrees in all over Europe, we can feed this electricity into electrolyzers, and then store this hydrogen, and then later, as I already mentioned, burn this hydrogen, CO2-free, because this is then so-called green hydrogen. It comes out of a wind turbine, it comes out of a hydro plant or of a solar plant. And then when the artificial intelligence sees now the demand comes up, now people getting home, plugging in their electric vehicles, start cooking, turn on the light or whatever, we can use this hydrogen and produce independently CO2-free electricity and heat, which is great then. So there's a strong push, and I'm in full support. And as well, my company has products in this area, and we invest millions as well with help of the European Union, of the Austrian government. We get funding, which is great as well, because you need more shoulders than one for such a breakthrough technology, because it still costs a lot, right? This green hydrogen, it's a lot discussed. I just saw it yesterday on German TV. It's still too high, the price, but I do see that we will come down dramatically. I do see that we had the same on photovoltaics 15 years ago. It was way too expensive. Look now, the story has game changed. And I do hope, I do believe that it will be similar on the green hydrogen.
Thank you very much for adding all of that. And I'd like to come back to Cosmas Alexopoulos, who's sitting in our first row. Now, hearing about the innovation push that we hear there in the energy sector, I'm wondering if you could talk about smart manufacturing. When we talk about smart manufacturing, sustainable manufacturing, can you perhaps just elaborate on some of the examples that we're looking at, things like predictive maintenance and many of the skills that we'll need to be bringing in to experience the same innovation push in that area? Get a microphone to Cosmas.
Yeah. Indeed, for example, take predictive maintenance that you have mentioned is a very good example of technology that is now mature enough. I mean, predictive maintenance is built and stands upon the shoulders of artificial intelligence, of data analytics. For me, is what I call the low-hanging fruits of artificial intelligence. It's something that the manufacturing industry really can collect and apply. And for this reason, it can contribute also to the issue of energy optimization, because if you are able to better maintain your equipment, then you avoid breakdowns, you avoid producing products that are what we call scrap. I mean, you cannot sell them, or even the machine operates in an optimal way. It does not consume energy. So this is a good example how the digitalization can help us with the topic of optimizing energy. However, new and predictive maintenance, I take it as an example, as you mentioned, is also a good case when it comes to address the topic of skills. Because, as I said, this technology is already mature enough, either from research projects or from commercial products. However, there are still gaps when you want to introduce this technology in the shop floor. And one of the topics there is skills that are missing, because it's a new technology, and this is what we got as a feedback from the companies that we are working upon. So for many years we're working on the technology side, how to develop this technology and apply it in industrial cases. And then the industry said, okay, the technology is there, but can you help us using it?
So does this bring us to the project that you can talk to us about today? Because you're actually here in wearing two hats, as it were. Skills for PDM, which aims to bridge the gap in the manufacturing workforce's skill set. And so that's, elaborate a little bit on that for us.
Exactly. This was actually the motivation for Skills for PDM. Skills for PDM stands for Skills for Predictive Maintenance. And this was the motivation. Companies like the ones that are in the project, namely Whirlpool, which is a very big company you all know, we all know, informed us on this gap. Here is technology, but how we are going to use it. And we said, yes, of course, we need to create new skills to help people build new skills in order to be able to develop, deploy, and maintain these technologies that they may bring the benefit they're supposed to bring, but they are still complex and people are not used to work with them. So Skills for PDM, the project that we are referring to, was built to address this need. And what we have done, we have created a consortium from 3 countries, from Greece, from Germany, and from Italy. And we put down the basis and the needs for predictive maintenance. We have identified the different roles that are involved in this process, namely the managers, the technicians, the maintenance technicians, the machine operators, the engineers. By the time we have identified the roles, we, together with our colleagues, start developing training and learning material in order to be able to explain and introduce this concept to them. Having done that, then we went into a process of deploying and applying this new training material to the people. Initially, we had a session that we call Teaching Factory session, that is practically a remote session to bring together what we are doing in the universities and the research organization with the industry to introduce the concept. And then we had a number of physical meetings in the industry to, let's say, to be able to present lively what is the technology about and how to use it. And right now we have developed more than what we call nuggets, learning and training nuggets, more than 60 of those, and that are available in the Skills Move platform of EIT Manufacturing, and more than 10 learning paths that target individual profiles in the industry. And of course, this is also part of, it's an outcome, and it's also part of our exploitation path for how to use it in the future.
Thank you very much for telling us about that, Cosmos Alexopoulos. And it's interesting because we've heard a lot of sort of these terms, smart manufacturing, predictive analytics, and maintenance. AI has been mentioned a number of times, and I'm just because the pandemic, of course, taught us an awful lot about how intelligent systems are key to optimizing manufacturing processes, and particularly for planning in terms of when it comes to crisis situations. So I'm wondering if perhaps we could get some input, and then we'll go to the next project, from Martin and possibly also from Bastian on how something like digital twins can help. Martin, are you employing these already?
Digital twins, yes, for sure. We are always, when we design a new product, first we create the digital twin. We create a 3D model, and we even can, in the meanwhile, simulate then the whole production flow with that. Mm-hmm. So we can see it, we can touch it with a ER, Google, right? So I even tried it myself several times now.
With a VR, you mean?
VR,
virtual reality.
Yeah.
Okay.
Yeah. Augmented reality.
Augmented
ER
reality.
or VR, yeah.
Yeah, AR.
And
okay.
As well, then we can machine it. We see how it how it performs on the machine, and if there are any breaks or whatever on the machine, we see the lead time. And then we see the finished digital twin then as machine part, and then we even can do assembly trials. If the assembler then on the assembly line can reach it with the tool and whatever. So it's a very important element to reduce the time to market, digital twins. And it saves as well a lot of unnecessary energy and resources.
Mm-hmm. Bastian, can you comment further on the use of intelligent systems and which ones are particularly being employed now to help in energy production?
Well, I think, first of all, what the pandemic situation made with us is it increased our creativity, because we had to look at the same things in a different way.
Necessity is the mother of invention.
Unfortunately, in this case, I need to say. But for instance, if we have these digital twins or AR models we just heard, we also thought about how we now work together. So even that has changed by now, because we are forced with work from home or to work from home. Indeed. Or to work more distributedly. But this also gave us possibilities to really dive into certain things we haven't had a look before. Because we thought, okay, we will do it the old-fashioned way. Now we had this force, as you said, the necessity to do this. So I wouldn't tie it entirely, all the new digital or AI or smart and digital twin-based solutions to the pandemic situation. But it was just the switch of perspective that really fostered certain innovations here. What is good to see in the end, because I think, especially academia, and Paola, I hope you will support the statement, we had a couple of solutions already like in the draw. It was more about the industry to really pick up concepts and try to implement them on the shop floor and learn, which was also a good experience for us, because when we say it works in our shop floor, that's a very ideal environment we created, or to a limited use. Now we had the opportunity to work together with industry again and to see these concepts or innovations really in action and improve on them.
Thank you very much. Paola, do you have anything to add? I see you nodding your head.
No, not particularly. Now, yes.
Okay, then I think we'll move on forward and go bring in another one of our projects because Anna Shimoesh is here. There she is, yes, absolutely. And your project is called Demo for Green, which aims at spreading the demonstration of technologies that reduce the industry's carbon footprint in existing high technology infrastructures of RIS, Regional Innovation Scheme countries. Can you tell us a little bit more about how that is contributing to sustainable manufacturing?
Yes, thank you. Thank you for the invitation. My name is Ana Simões. I'm here representing the Demo for Green consortium. I'm a researcher from Inesctec, that is a RTO in Porto, Portugal. And this consortium is formed by 8 RIS countries. It's Portugal, Spain, Italy, Greece, Poland, Czech Republic, Lithuania and Estonia. So we are 8 RIS countries trying to demonstrate some green technologies in our teaching learning factories. So this project has 3 main phases. The first one was to develop a training program that the main subject is how to implement a demonstration on our teaching learning factories, aiming to show the circularity and the sustainability issues of the technologies to be demonstrated. The second round was regarding an open call that was open to every SMEs, mainly startups and scale-ups, that have green technologies to demonstrate and give them an opportunity, show them in our teaching learning factories. The third part that is now running is the demonstration of 8 selected demonstration technologies that are now being demonstrated in our labs, in our teaching learning factories. And these technologies are from a broad scope of technologies. All of them, as you said, are green technologies. At one way, reduce the consumption of the energy or contributes to circularity. We have a broad scope, as I said, of technology. We have systems that gather data to contribute to the rationalization of the consume of resources. Other that are based on for example, the energy panels to the agriculture. The other one based on the 3D printing, how to use different materials to be used on this kind of technologies. So we have a broad, nowadays we have a broad range of technologies that are being demonstrated in our teaching learning factories. So this is what we have now in Demo for Green.
And tangible outcomes, or where you think this is going? So
now we have trained more than 40 participants on our first training program. Then we have more than 50 companies, more startups and scale-ups that were interested in our open call. Unfortunately, we only have supported 8 of them. The most that most contribute to sustainability issues or circularity that were evaluated on this sense. Now we have 8 demo events that are running in our teaching learning factories that enable companies to show them their technologies to possible customers that can have that where they can test before invest these kind of technologies, as well as we are mentoring and coaching these companies, these scale-ups and startups with topics related to business models, innovation on IP issues, and communication aspects also, broad topics that we intend to mentor them and coaching them. And as a future, we intend, as in a Demo for Green 2 project, to be on deep on these issues and support companies on the innovation journey and bring them their technologies into the market.
Thanks very much for presenting that project, Demo for Green. And we're talking a lot about reduction of energy consumption. And it's very interesting because one of the key criticisms of all of the digitalization and these many, many technologies that we're hearing about and the IT infrastructure necessary to support it is that it's incredibly energy intensive. And this is obviously something that everybody has to take into account with their entire energy and carbon footprint. So I'm wondering if I could pull Bruno Puzzolante back into the discussion, and if you could tell us what are the best metrics for businesses to actually monitor their energy consumption, considering that it's not only about their manufacturing processes, it's about all of the support structure to monitor what they're doing.
Okay, when we are talking, of course, on adding new digital technology to the shop floor, to the manufacturing plant, we are thinking of adding new machines, sensors, edge computing on the plant, then eventually also local connectivity, internet connectivity, and reach the cloud where some probably applications are running and consuming a lot of energy. So this is just a part of the equation. Means that at the end they are cost or investment, operational cost that I have in my overall use case. But I should also take in consideration which is the impact of the use case that I'm going to implement. So introducing a digital technology can help my manufacturing. I should take also into account how much I'm spending. So of course now it's a matter of with the energy crisis to take in consideration, but it should be part of the equation in general. And referring it in particular to the aim of how I can monitor my energy in my plant, how I can look into a solution that allow me to really understand what's going on. Of course, I should take in consideration what are the smart meters that are at this moment really widely available at also at the shop floor level. So this means try to have the monitor of the energy consumption at a granularity that is not only on the time, but also on the area within the manufacturing. This can allow me to put together this information and look for an optimization of the consumption that is made by, from one side, the awareness of what I'm really doing, what I'm really using as energy. On the other side, I can then optimize and look for new way to improve my production on the floor.
You mentioned plant assessments, and I know that that's something that you're very involved with. You've done, I'm not 100% sure how many you've done, but you're very involved in sort of helping companies along on their sustainability journey. What are the trends that you're seeing? How many of these, what are you seeing from these plant assessments that you've done, and how can production facilities, where do they start when it comes to improving their sustainability?
When they come to us for look for improving the sustainability, they should start as also we did in our project, Massi, that then I will have time
which you can tell us about right after that. Absolutely,
okay.
Yeah.
The first step is the awareness. So let's start to understand which is my sustainability footprint. Sustainability that should be evaluated across the different pillars that are usually within the sustainability topic. That is not the environmental one. And recently is also coming more, apart from the environmental, also the social aspect and also the economic as additional pillars that together with environmental make the overall sustainability. So this is the first step usually the manufacturing plants are asking. So let me understand where I'm in terms of maturity regarding the sustainability, because this is the first time. Be aware of what is my position, can help me then in define a path, a journey for sustainability improvement.
So you mentioned Massi, which is of course the project that you're here representing as well, with a bit of a double role. It offers solutions to support plants of manufacturing companies in their sustainability goals, which you've just elaborated on a little bit. What kind of an impact are you expecting from Massi?
With Massi, we are expecting to help the manufacturing plants that want to start or are willing to start the sustainability journey. In a way that the MASI stands for, it's really an acronym that stands for Manufacturing Assessment for Sustainability Strategic Insight. So from the assessment, we want to go to strategic insight on sustainability. This means give at a glance view to the corporate level, but also the plant level, information, insight that can help the decision makers. We defined the Massy project, the solution that we developed, starting from the fact that currently the approach to sustainability is, let me say, a corporate approach that is not lack of connection with the manufacturing plant. So this not give the right answer to really go and understand which is the initiative that I need to apply at plant level. Other approaches are more related to, let's evaluate the production sustainability of a specific product on my plant, means something that is really specialized and needs to be used, addressed by experienced professionals on the field. So something that is not related and is far a bit from what the decision makers within the company needs to have at their view. So we developed Massy having this in mind. So with the aim of evaluate the sustainability at plant level. So the idea is to, within a single manufacturing company, assess differently all the plants through an effective data collection that is delivered leveraging an application. So a simple survey, let's say, that is delivered on the web, and the analysis of the data that we collect, giving at a glance view of what is the sustainability level for all the main pillars, but also with the possibility to drill down and really understand which are the causes that are behind a specific situation. So this can help me understand how the energy that I'm using, how is the characterization of the energy that I'm using in the specific plant, how much is the percentage of material input that I have in terms of new materials, of something that I'm reusing in somehow from the production that I already did.
Thank you very much for that explanation. And a lot of we've talked about sustainability at plant level and sustainability assessments there. I'm going to bring another topic in here because I want to go to the project that's entitled CAMP, and I think Dirk Herzog is here with us. There he is, very much in the back. If I could get you to maybe just move up a little bit into the room so that the camera can find you. Dirk, you are representing the project CAMP, which is Professional Certification for Additive Manufacturing. So that's the new element that we're going to bring into this discussion, because additive manufacturing is also helping to reduce energy consumption. What insights can you share on this project? Tell us what it's about and what kind of tangible results that you've achieved.
Yes, okay, yeah. Thank you very much for having me here and presenting the CAMP project today. You mentioned additive manufacturing as being a technology that can help in reducing energy consumption. There's some bad news maybe to start with. Not per se is additive manufacturing resource saving, energy saving technology. It's only when we use the design freedom of additive manufacturing, when we understand how to use additive manufacturing and how to leverage the potentials we have through additive manufacturing to design products that are better than the products we produce today. That's when we actually have an advantage of additive manufacturing. Yeah? So basically, this really makes the difference. We have to look for the design of the products. And there are actually two aspects that we need to look at here. That's the design of the product that can be maybe much lighter. If you're looking at aerospace products, we can design products that are maybe 30, 40, 50% lighter than we could do using conventional manufacturing. That's an asset. And it's also in the area of the manufacturing itself. If you don't understand how to design a part that it's manufactured in a good way through additive manufacturing, then you will have a lot of post-processing operations, spending a lot of resources there. And actually, if you spend resources, this always means you're spending material, energy, but also money in this. Yeah, so that's something that usually goes along here very well. Coming to the project itself, it's actually called Certified Additive Manufacturing Professional for designers. So here we are looking at the skills that are actually needed for designing parts. Of course, there's trainings for designers already in the market that are taught. We are actually looking for or developing a certifiable educational learning path here that can actually leverage this, that it has a homogenized teaching program, learning outcomes, of course, and in the end, we expect to have designers with a certification that will also help, we expect, to attract people into this topic. That's another problem we have to tackle, actually. By coincidence, this week, the largest 3D printing fair is taking place in Frankfurt, Formnext. If you go there and talk to people, of course, everybody's looking for customers at a fair, but people are looking actually for personnel as well, because they're in desperate need for this. Mm-hmm. So that's also a very important point we have to look at. How do we get all this personnel into these kinds of topics, and how do we attract these people? Because there's definitely competition worldwide for the best heads and the best skilled people here in these areas as well.
Thank you very much. That brings us back to the question of skills. Maybe before I go on to the last project, which I believe is the entrepreneurship, when you talk about the design level, we heard Martin talking about designing already for refurbishment and for recycling. Is that also how additive manufacturing can be used? Or is it simply from a more economic design from the outset? Or is it actually looking at sort of further life of product as well?
Of course, that's one aspect as well. It's maybe not the first aspect you're looking at, but it's something, if you take a look at it on a holistic viewpoint or level, of course, that's something you also want to address. One point we can make here is using additive manufacturing, we can do some kind of integral design. So basically, we can have maybe a structure that's larger, using the same material, more easy to disassemble in the end. These kinds of aspects are also going into this. So to make the life easier of people who want to go in this direction as well. Yeah.
Thank you very much, Dirk Herzog, for telling us about certified additive manufacturing professionals, and an interesting project there, bringing up the question of skills. And with that, I'm going to come to Marta Molinero, who is here representing the project Entrepreneurship, and she is the Risk Collaboration Manager. So your project is focusing, if I understand correctly, on both the social and environmental aspects of sustainability, which takes us really away from some of these other projects. You don't actually have a physical product. You're more looking at kind of work environments. Can you tell us what the Entrepreneurship Challenge is actually about?
Yes, thank you very much for your question. I'm Marta Molinero. I'm Risk Collaboration Manager at the Risk Pillar of EIT Manufacturing. And Entrepreneurship Challenge is a competition that aims to attract, select, and support manufacturing end user and workers from EIT risk country in developing innovative projects with the support of solution providers to make their works more safe and to also make their industrial processes more environmental sustainable, and also to support the manufacturing end user to overcome different challenges, both from the societal and environmental point of view. So what is very important and also related to skills in these challenges that we launched this year for the first time is the role of the intrapreneur. The intrapreneur are the employee of the manufacturing end user, and they have to identify the technical challenge that they face in their daily production processes that need to be solved. So the challenge will be then solved by the manufacturing end user together and in collaboration with the solution provider, but also with the active role of the entrepreneur. So how we support the applicants and the challenges that we selected. The activity provides some financial support, up to 50,000 euros per project, and also some in-kind support in terms of, for example, business training in order to help the applicants to deploy the solution in a more efficient way and to put it on the market. So actually, we also have at the end of the project some monetary prize for the best 3 entrepreneurs that will be selected. So what we are looking for is to help solve some societal and environmental challenges, as you said, in the daily production process in EIT risk countries. And for this reason, the main criteria that we have to select the application are related to the benefit for the workers inside the manufacturing and user facilities, but also we take into account the environmental aspects and improvement of the environmental sustainability, and as well the reuse of existing material. Mm-hmm. So, for example, for this year call, we have selected 8 challenges from 7 EIT risk countries, and for a total of 16 companies between manufacturing and user and solution provider who are involved in the projects, and 8 entrepreneurs. So the challenges come from different type of industrial sector, as for example, dairy, plastics, automotive, and different type of industrial materials, stone materials. So we are happy of the results that we are achieving this year, and we plan also to open the call next year.
Thank you very much for describing that very, very useful project and looking at aspects that we don't necessarily always talk about when we're on the ground and in the shop floor. I'm wondering if any of our panelists have any, that was it for the projects, and I'm wondering if there are any questions for our activity leaders from any of you on stage or possibly in the front or possibly also our virtual audience. You can certainly be putting your questions in. And did I see a hand go up over there? Yes, can we get a microphone for the gentleman over here on the far left?
Thank you. My name's Dave Peck from Delft University of Technology in the Netherlands. As an academic, I think this has been lovely, and I'm loving hearing about these projects and activities and companies. But as an academic, I want to throw in some provocation, because it's got a bit cozy and nice. Okay, so let me throw you some challenges. Don't worry, I'm not going to be too harsh, but let me just throw some things in here. And I'm missing something. And what I'm missing is time. So we heard Klaus talk about time, cost, quality in the beginning, right? Mm-hmm. So I was in manufacturing for many years. It dominates your thinking, right? So where's the time? Let me give you 3 examples that I want to ask questions on. Number 1, we heard deep tech skills, 1 million people. In the Netherlands, we're 100,000 engineers too short. Mm-hmm. And now we turn to time. We have 2030 deadline, right, for our climate and twin transition goals.
You can't train that many engineers in that.
Well done, thank you. We can't do it if we're talking about young people coming into our universities. My university is going from 27,000 students to 40,000 over the next few years, 5 to 7 years. Mm-hmm. So some of them will be coming in nearer the end of this time. It's not going to make it. So that's number 1 challenge, time challenge. Number 2, Fit for 55, Repar EU. If you don't know what they mean, they're going to dominate our lives. 55% lower carbon emissions by 2030. Not 2050 or 100, 2030, 7 years. This year's nearly over, right? So Delft University, we've just secured 100 million euros to get us net carbon zero by 2030. So do the rest of the university partners have 100 million spare to do this? I don't think so. So that's another challenge for the university partners.
So that was cost.
That's how much we're going to have to spend to get us to net carbon zero. We will do it, but it's going to cost 100 million just for my campus. And then the third one, and this is the killer, and it was mentioned by Klaus in the beginning, the materials requirement, right? Our twin transition, digital and energy plans by 2030 to match the Fit for 55 plans. Here's the bad news, folks. European manufacturing cannot do it. Cannot do it because of critical material supply and demand. You will not get the materials you need. Recycling will not fix this. So in the Netherlands, the government has said 50% less primary material by 2030. 50% less by 2030. 2025, 25% less. 2023, 10% less. Which one of the partner companies has any plans to do 10% less material by next year, 25% less in a few years after that? I don't think anyone's got those plans in hand. So those are three massive time-bound challenges, and I see my academic colleagues nodding their heads because they're also doing the same research that we're doing. And I think that's one of the major things we need to look at in EIT manufacturing. But I'm interested to hear what others think. Thank you.
Thank you very much, David, for those extremely important observations, materials, and I mean, it's not by accident that we have a sister EIT raw materials, working very, very hard, obviously, on trying to resource and find some of those resources here within Europe when we get to the question of independence. I'd like to put your questions and your challenges to the panel, and that includes the two gentlemen in the front here, Bruno and Cosmas. Paola.
Yeah, I can
yes,
take a part of the question because they're about deep tech talent initiative. Of course, we are fully aware of the challenge of 1 million upskilled in 3 years. But we need to interpret this not like, deploying engineering studies. That would be part of the solution. But of course, for example, we address researchers that are already very proficient in deep tech, but in order to deploy the full potential, they might require some business skills, entrepreneurial skills. So this is, for example, a target group that we would like to address, and maybe in a limited time we can bring them back from university where they cannot maybe find developing careers because only few jobs, as you know very well, are for professors. So they need to find their way in the industry, in the business, and this is how we can make it happen, for example. And then also we address maybe people that already have some basis but need to, get some deeper skills on one specific. So it will be a mixture of elements that hopefully will help anyway Europe, whether we achieve in 3 years exactly 1 million, or maybe 1 million will be a little bit later. But the important thing that we start with a lot of energy in order to make this happen.
Thanks very much, Paola. Bastian, I'm sure you've got some comments on that triad of challenges that, we know the ugly truth is we're trying to be positive and looking at how we're going forward with all of these initiatives, but obviously that 2030 deadline, 7 years are over like that.
Exactly. And I really like that you came up with these 3 challenges. And just for instance, if we now look at all the gigafactories currently planned or built up in Europe, we will struggle to have the material, as you just said, because these are really critical materials that we cannot source in Europe, at least not to that extent. So yes, we, for instance, Paola just mentioned hydrogen. We need to look for alternatives maybe, but also when it, for instance, comes to these batteries, and we heard this already, we need to think of the circular economy in the end. So we cannot really rely on virgin materials, on the primary materials. We need to really close the loop very early after the use. And this will require a lot of effort from all of us. However, we also need to think of an opportunity, of course, with this entrepreneurial skills, for instance, to come up with new solutions, to come up with a different approach to try to serve the customer needs, and maybe come up not with a car production plant or car manufacturer in the end, but a mobility provider, which has far other opportunities to recycle, to refurbish, to remanufacture, reuse. So all the R's up to the customer, basically, to the repair in the end, to early on close the loop to make the most we can of these materials, and of course improve, for instance, the recycling technologies or all the technologies in the end to have a higher yield, and maybe even to equip our products with more information. We already heard about the predictive maintenance, for instance. This is a very good example from a perspective of a manufacturer or the operator of this machine. However, you can also think from the perspective of the manufacturer of that machine. So can we maybe implement some additional sensor technologies to see what happens with the machine during the lifetime or with a product during the lifetime, and early on figure out, okay, this product will be used or can be reused in a second life cycle, or we need a special treatment, or if we only replace that one particular component in the next 3 months, maybe that's already sufficient to increase the life cycle of these products.
Thanks very much, Bastian. Any comments from you, Martin? Or?
Yes, to your first challenge, so thanks for the challenges as well. First challenge I see here, I see it's a big issue, but I say don't give up, even if it's far away. And one gap closer I see is there will be many people released out of more automation, more digitization. Many, I would say, shop floor workers, people on the ground. And we see this already in our company. We need to upskill those. We need to train them. Some are really willing even to start then a study, to start studying, to do additional education in the new areas of sustainability, right, in this economics. And I think we need to attack this. We need to attack then, there is always this discussion that the combustion engine will end, right, especially the automotive. There is a strong fear, especially in Germany, in Austria, where the automotive industry is really strong, that thousands of people will be laid off, right? We need to use those people and need to upskill them, reskill them, retrain them, use them. So that's the second. And the third is women. We need to attract more women for technical jobs, for manufacturing, for developing here manufacturing goods. I think this is a third one, the rest, it's a challenge, I agree, but don't give up. We give up a letter, nothing else is always my motto. Yeah.
Absolutely, we have to start somewhere. That 2030 and 2050 are certainly daunting goals, especially when we see what comes out of Glasgow and Egypt. I mean, it's always much more talk than the actual action to get things done. So I'm wondering if there are any other questions in the room or responses to David's comments and challenges. Are there any questions from our audience? Otherwise, I can continue merrily on. I have a couple more things here. Paula, I'd like to come back to you. I mean, skills and women. I mean, how to get more women into STEM, how to make these manufacturing professions interesting. I think that's, and it's interesting that I think it was Dirk mentioned the word holistic. I made a note here. I'm just wondering how the EU manufacturing industry and the sector itself can develop this more holistic view, really, to be attracting new generations, to get them excited about. There's going to be 1 million jobs out there. People have to get excited about that.
Yeah, I think there is already a trend ongoing. Manufacturing is becoming cleaner, is becoming less physical, is becoming more digitalized, yes, more smarter, as we have seen today. So it's quite natural that it is already, more suitable for women, but we need to do more. We need to convey this image of smart manufacturing, where there's a place where also creativity, for example, find this place, where there are also societal objectives and goals we take care of for the environment, we take care for the local community and for the people inside the company. So that all these messages are not restricted within the factory, but this image can go beyond the factory. And what we also do together with other sister KICs is also going to the school and help, especially girls, but everybody to develop new skills on digital, maybe also with additive manufacturing to design products. And in some projects, for example, one way in which that they found to engage more girls was to exactly put on the table challenges that have to do with health. For example, we have this idea of manufacturing mostly related to automotive industry, transportation industry. That is something maybe more from the last century. Now a lot of new manufacturing is coming in for producing medical devices, a lot of objects that are prostheses, a lot of things that are really relevant for our daily life, but also for our health. And I think this transformation will also help in attracting more women to the manufacturing. And of course, we need to change sometimes the mindset in the manufacturing industry. In some cases, it's still a little bit dominated by male, with the hierarchy is also very much it's higher than as a mindset than in other sectors like the digital sector, where we have a flatter organization and more creativity.
Thanks very much for those comments. Any other comments or questions from the room? Do I see any hands shooting up here? Yes, Nicola.
Let's give it a try. Do you hear me?
Yeah. Yes.
So I work at EIT, which is Hub Innovazione Trentino. We are a technology and knowledge transfer foundation, non-profit in Trento. So we are an intermediary actor in the area, in the province. We also act on an Italian and European level. So we stand like in the middle of what companies, researchers, and also public institutions should do to create innovation, and we act as an intermediary. So I found out how much important it is to have intermediary players into EIT projects overall over these years, not only within Flexman. Within Flexman, we have to reach out to SMEs and convince SMEs to take up a course. 40 hours involving maybe 5 to 8 people, over the course of 2 months, 3 months, and they also have to pay a fee because we have to create a sustainability. So it's really hard to convince companies, especially SMEs, to do so, okay? And if we want to upskill, if we want to reskill people, we need to convince these kind of companies to do so. And that requires marketing competencies, sales competencies that most of times universities don't have, research centers don't have, most likely companies have, but they're not interested on, promoting these kind of courses maybe. So as far as we need to reach out to companies or players that are outside of the KIC, and this is going to happen more and more since now projects are open to companies and players outside of the KIC. In my opinion, it's going to be crucial to have into projects partners that are playing this intermediary role. So they're not, research, they're not education, they're not business, but they sort of try to bridge the gaps that are required when it comes to reach out to players that are outside the project and outside EIT. Okay.
Thank you very much, Nicola. Paola, would you like to respond to that?
Well, I think it's a very interesting question, and we are exactly pushing to evolve in our partnership also training providers or intermediary roles in order to play this. But I would like to also maybe to relaunch the ball to 2 people, if I may, because we have heard now that companies need upskilling. So I would like to listen from the voice of the company what are the barriers in order to get, or what type of training they would like to find, And also to Gregory, because I think he has, no, sorry, Gregory, to you from Delft, Peck.
David.
Sorry. Because Gregory Peck creates a shortcut in my mind. Sorry for that. Because I know that you have involving a lot of companies with your workshop, so maybe also to listen from your voice. And of course, we have already heard about Nicola, how he dealt with this. So maybe to have if you allow me.
Absolutely.
Yes.
Martin, perhaps we can start with you. We are keeping the answers brief.
As I mentioned, there is a clear need. And you said that probably companies see this and need this, but you don't know if they really do something. In our case, we do something. We will invest money. We will start next year with a so-called My Academy, which will be an internal, not a university, but a training center where we upskill and reskill people. But we don't do this alone. We partner here with local universities in our region, with local education centers on different topics, on digital, on lean, on green technologies. And people who are released out of an automation project, where now robots do the work, they getting upskilled now in digital because they need to observe now those robots. They need to, if something doesn't work, they need to fix it. They need to teach the robot, whatever. And as well in the area of sustainability, we have different jobs in the meanwhile in our company who focus 100% only on sustainability, on waste management, for example, on waste recycling, on increasing the content, and. So there are many, many jobs, and we take it in our hands. We steer it from the My Academy. That's the name, the vehicle driving forward. But we partner here with other stakeholders and hopefully can upskill our workforce and have the right skills then in the next 3 to 10 years.
So in this case, the intermediary, if I get it correctly, is your internal academy, right?
Yeah, internal.
Yeah. Okay, thank you. And maybe...
David, did you have anything more to add before we try to close off? Have you got a question from the public? If you could bring them to me, please, that would be great. I don't see anything on the screen here.
I'd really like to pick up on the gender
issue.
Yeah, that's a super opportunity. We talk about hundreds of thousands, millions more people. Well, 50% plus of the population of Europe is female, and we miss that. I'd also like to expand it a little bit more, and we need to go wider in exploring diversity and inclusion. It's not just gender. I'll just leave it there. But that's something we're working on in Delft as well.
Well, it's good to hear that you're working on that. I've heard that we do have a couple of questions from the public, and I'm going to have to come over here to be able to read them because, unfortunately, this monitor is not showing them for me. So Alexandre Braconnier is asking, he says, hello, everybody. Following on the comment on the financing gap, fortunately, there are investment funds contributing to the financing of tech startups. Is there an annual conference from EIT Manufacturing where investors can hear and meet startup pitches? Paola?
Yes, well, I'm not the expert on because it's about business creation, but of course we create a lot of opportunities for startups to meet investors, and we have special programs for startups. So yes, maybe we will follow up with this question more specifically through my colleagues.
And thank you very much, and that would be the business development pillar. Carlotta Zantz also sends in a question to the panel, and she says it's clear, especially at the manufacturing level, that tech know-how is essential to design new technologies. But what about soft skills? Do you think it's important to educate in social skills, leadership, creative thinking, etc., to innovate? How can we educate the manufacturing community in this sense? Soft skills, obviously important everywhere, and it was a discussion at the last Raw Materials Summit. So yes. I'd be interested to hear your thoughts. If we can just maybe see if anybody's got some spontaneous responses to that question. Yeah.
I think it's very important. We should not forget social skills, soft skills. Our relation to each other is the key, I would say. All the, let's say, the technology and the theory doesn't work if we don't relate to each other in a professional and good way, right? We motivate each other and so on and so on. What I would say corporations clearly need to do it first to offer here trainings in terms of soft skills, right? Leadership trainings, innovation workshops, whatever. I think this is a baseline. And in the meanwhile, in our hybrid world, you can do this a lot online and with perhaps one day face-to-face and the rest online. You can get here a much bigger audience. And on top of this, what we do, and I'm a strong believer, which is strong, is mentoring and coaching. So having mentors in the company, open to getting here mentees or being a coaches, and then coach the coach, kind of this, because in a coaching discussion, you talk mainly about soft skills. That's my perception I have, and I think with that, when you build up a network here, that's very good and very important.
Thank you. Any other comments from?
I think
Paula?
Because there are signals, maybe from the
There's
audience.
a response in the audience. Sorry, didn't see that you had a microphone.
So Christian Belling, I'm the director of the Innovation Hub from EIT Manufacturing in Germany. I just want to add one something to the first question. So we have a lot of opportunities. So far, we don't have an annual conference for investors, but to just give an example, or three examples in a row. Last week, we have been active in Baden-Württemberg, south of Germany, having an investors event, bringing startups from all across Europe to that area, connecting them with the industry, with the investor community. My colleagues, beginning of this week, were in The Hague, where there was the Impact Fest, a great also opportunity to meet our startups. So there are a lot of things ongoing, and I'm quite sure that also with the post-COVID time, we will also think on an investor event, a yearly one. But so far, we have managed that on a local, regional level. Yeah, just to give a hint on that. Yeah.
Thank you very much,
Christian.
And going back to these transversal skills or soft skills, of course, they are core and they're, they complete the personality, the capacity of the capability of a person, the competencies. But I believe that it's also important to help learners to develop these skills not in a separate way, but together with hard skill. Because if you have traditional lectures with the professor speaking and nobody allowed to intervene, propose ideas, maybe only to ask questions at the very end, this will kind of prevent people, the learners, to develop their soft skills, and it will be harder to do that later on. So it's still possible, always possible, even in the future, but of course, a different type of education with hands-on activities, teamwork, challenge-based is favoring the development of the skills while studying and learning hard skills. I think this is quite important.
Especially given that we can probably assume that soft skills are possibly something that suffered the most under COVID conditions and the pandemic conditions. I'm very happy that we've had a lot of input at the very end here. Unfortunately, we've come to the end, so if nobody else has any burning things to add, we are going to have to wrap up this session. Anna Maria Corfiati, one more point from you, yes.
I want to talk about the development of digital skills. We are organizing teaching factories, as I said before, where we engage both students and employees, and we ask students to solve real industrial and specific problems. So we divide the students into several groups, and we give them the problem, and we request for them to analyze and analyze the problem and design the solution, develop the solution. And I think that this is very important for the students because instead of the digital skills, of the hard skills that they are developing, they also develop soft skills, that is communication with the other students and also the company. They learn to respect the real industrial deadlines, to manage time, to be creative, to be problem solvers, and so on. So, okay.
Good initiative and one that is highly necessary, as we've just heard. Well, thank you very much for that input and for all of these insights and inputs from the panel and from our project leaders. It was great to have you here in the room. It is time to wrap up the discussion, but I think what we've seen is creativity is high in manufacturing, and yet the challenges are rife, especially when it comes to energy reduction and sustainability. Incredibly complex transition going on with energy sources and bringing in renewables, but also looking to these newer and not quite mature, but also the maturing technologies that we see coming up are going to be very helpful. And great to hear that companies are also partnering with universities and getting in on the education game and the formation space, so that a lot can be accomplished through collaboration. So I'd like to thank you, all of my panelists here, Martin, Paula, and Bastian, Cosmas, and Bruno, and to all of our activity leaders. And for those of you joining us online, we're going to break for lunch here in Brussels, but there is a lot more great content in our virtual breakout rooms. I'm supposed to alert you to this. And I hope everyone can use this chance that we're taking the break here for a networking lunch in Brussels to power up on your end and see a lot more projects and results of what's been done across the network and the ecosystem during 2022. So grab a snack, and from all of us here on site, we'll see you back here in 90 minutes. That means 1400 sharp for our second roundtable discussion. Until then, all the best, happy searching, and bon appétit.